Lesson 11.3, found on page 443 of your big book, continues the concept of finding the surface area of prisms. So how can you find the surface area of a prism? You can use a net to find the surface area of a solid figure such as a prism. Okay, so Alex is designing wooden boxes for his books. Each box measures 15 by 12 inches by 10. Where's our 15? All right, so there we go. 15 by 12 by 10. Before he buys wood, he needs to find the surface area of each box. What is the surface area of each box? So that he buys the correct amount of wood is why he needs to figure this out. So first we need to determine what is the shape of each face on our box for these books. Well, it's a rectangle. All of them are rectangles. We have no other shapes in the faces. So we're going to use a net to find the surface area. So this is like if we did in previous lessons, if we cut this side and opened it up, flattened it out, this is what this shape looks like, flat, two-dimensional. So now we're going to find the area of each lettered face. So what they did was, so this is essentially C, this is B, this is F right here, A is over there, see D is on the bottom, and E is this other face over here. Okay, so they took this, flattened it out. Find the area of each of these lettered faces. So face A is 12 by 10 inches, which is 120. Face C, this one right here, is 12 by 15 inches. Let's do a little margin work and find out what that is. We've got a 10, 1, 2, placeholder 0. So we have 180 inches squared. Face E now is over here, right here, which is also 12 by 15. So C and E are the same. This, what did I do wrong? Oh, this is wrong. Sorry. This, I can't erase. Okay, this is actually D over here. B and D are opposite of each other. C and E are opposite of each other. All right, and which means that they're the same if they're on opposite sides of the rectangular prism. So C and E are the same dimensions. So B and D are the same dimensions also. So this is 150. This is also 15 by 10, which is 150. And finally F, which is the same as A. These two are the same, which was over here, 12 by 10. 12 by 10 is 120. All right, so now we have to find the sum of all the areas. So we have 120 for A. We have 180. We have 180 again. We have 150, and another 120. I'm going to put that up here. So we have two 120s. This is 120. This is 120. We have two 180s. That's this one and this one, and two 150s. Okay, so now we're just adding all of that up. All right, so obviously a whole column of zeros is 0. 2 plus 2 is 4, plus 8 is 12, plus 8 is 20, plus 5 is 25, plus another 5 is 30. Regroup the 3. 3, 4, 5, 6, 7, 8, 9. So the answer is, after we've added them all up, 900 inches squared. Notice that we have inches squared on each of these because you've multiplied inches times inches. That makes 2 of them, therefore they're inches squared. All right, so so the surface area of each box that he's going to build for his books is 900 inches squared. That'll also tell him how much paint he needs to buy if he wants to paint his boxes at the end. Okay? All right, let's look at this different solid figure. So here, some of the faces are triangles. Therefore, this is a triangular prism instead of a rectangular prism like the one that we did on the previous page. All right, the surface area equals the sum of the areas of the 3 rectangular faces. Right, there's one back there, one right there, and one right there that are rectangles. Okay, so we have 3 rectangular faces and 2 triangular faces, one right there and one right there. Note that the bases have the same area. The bases being the triangles also. So this is essentially, this is A, this is E down here. This little triangle down there is an E. Then we have D and C. This one back here is definitely B. A, C. So this one back here would be D, and then this one, yeah, this one in the front, this right here is C. Okay, so the areas of A and E, the little triangles, or the area formula is area equals 1/2 base times height. So 1/2, 12 times 5. So 1/2, 12 times 5. 12 times 5 is, oops, I'm sorry, is 60. So 1/2 times 60 equals 30. All right. However, there are 2 of them. So A equals 30 and E equals 30. They're both 30. All right. So the surface area of B, this little one, is 5 times 10, which is 50. The surface area of C in the front here is 12 times 10, right? 12 here, 10 here, and I got that from this. So this is 10 right there, is 120. D is 13 times 10, which is 130. So surface area is, now they started this with 2 times right here. The reason being we have 2 triangles. So 2 times 30 because there's 1, 2 triangles, which is 60, right? Plus 50 plus 120 plus 130. So now I add all of those up. I don't add well horizontally. I do much better if they're stacked up vertically. So that I'm going to do a little margin work. I'll come way over here. So I've got a 60 for my 2 triangles. That's where the 60 is coming from. 50 120, 130, add them all up. Whoops. I have 6, 11, 13, 16. So 360. All right, so the surface area of the triangular prism is 360 inches because that's our unit of measurement, squared because we're multiplying inches times inches. Okay, so find the surface area now of this cube. We're just going to do the same thing. This is the cube. This is the same cube flattened out. Find the area of each face. All the faces are squares with a side length of, so if it's a cube, let's look at a cube real quick. If it's a cube, all the sides are the same. So we only have to find the surface area of one of those and then multiply it by 6, really. But they're going to walk you through that. Okay, here we go. So using a net, here's our net. All those faces of a square with a side length of, let's see, 5 centimeters. So the areas of of all the squares are the same. So the area of one face is 5 times 5, which is 25 centimeters squared. Find the sum of all 6 faces. A cube has 6 faces, right? Like a piece of dice. So we have 25 plus 25 plus 25 plus 25 plus 25 plus 25 equals, well, that's 50, 50, 50. So that'd be 150 centimeters squared. Okay, so multiplication is just adding fast, right? It's the same, it's just, instead of having to write out all of this, basically we're going to go 1, 2, 3, 4, 5, 6, 6 times 25, which also equals 125. And that's what we're doing here, just so you understand, because they're going to throw in some new symbols and things, but this is all we're doing. You can find the surface area of a cube using this formula. Capital S for a cube equals 6 times the side, a lowercase s, squared, where S is the surface area, and where capital S is the surface area, and lowercase s is the side length of the cube. Again, this is all we're doing. They're just writing it out formally. So here's our formula. S equals 6 times the surface area, I should say. The surface area of the cube equals 6 times all the sides squared. So replace S with 5 because each side length is 5. So first we, according to order of operations, we do our exponents first. So 5 squared is 25. 6 times 25 equals 150. If you need to see that this way, I can do it. That's 30. 6 times 2 is 12 plus 3 more is 150. So the surface area of the cube is 150 centimeters squared. It's all the same, no matter which formula you use. All right, let's take a look at our notes. So basically all we did today was you take a solid figure, open it up, and make a net. So we're going to use a net to find the surface area of solid figures. First, we find the surface area of each of the faces of our solid figure. And so here's all the faces of this figure. Find the areas of each of them. Then we add them all up. That's all there is to it. Find the surface area of each figure in the net, add them up. and there's your answer. So this is our final answer. Okay, good luck.